Alright, so in this video we'll be looking at percent error. And percent error is something that comes up in practically every chemistry class and chemistry lab, so it's important that you're comfortable with it. So let's start off by looking at the formula for percent error. Percent error has a pretty straightforward formula. Percent error is going to be equal to the absolute value of the difference between your measured and actual divided by your actual. And this entire thing, this fraction, it is going to be some decimal, right? And so since it is percent error, we're going to want to multiply this whole thing by 100% in order to get our answer as a percentage. So this here is going to be your formula for percent error. So again, that's going to be the absolute value of the measured minus actual divided by actual. So what does that even mean, right? Your measured means the value that you actually got in your experiment, right? As the name suggests, is what you measure. It is the data point that you collect when conducting the actual experiment. Your actual is the value that you should have gotten. It is that theoretical value, right? If you remember back to when we were talking about percent yield in an earlier video, we talked about the theoretical value, right? Or your theoretical yield is basically what you would expect to get based on your stoichiometric calculations. So similarly, your actual, again, is what you should have gotten. It's that accepted or theoretical value. And the reason why we have an absolute value is because percent error always is going to be positive. And so you need to remember to always have that absolute value. And so if you're getting a negative percent error, you've done something wrong with your calculation there. You could be asked for just your error in general, or your signed error is also what it's called. And in that case, you can have a negative number, and we're not going to be having this absolute value. But when we're trying to do percent error, remember that value should always be positive. And again, remember now after we take the difference, the absolute value of this difference, you're going to remember to have to divide by your actual value once again, not the measured value. That's that's a common, mistake that students tend to make. But anyway, this formula is straightforward enough. So let us look at a problem. Let's say that your lab group found the density of aluminum to be 2.65 grams per centimeter cubed, and we know that the accepted value, right, or that expected value, that is going to be 2.70 grams per centimeter cubed. What is going to be our percent error? Well, so the density that we found in the lab, right, that is going to be our measured. So we said that we measured, let's just label it as M. Our measured was 2.65 grams per centimeter cubed. And our the actual accepted value for the density of aluminum is 2.70 grams per centimeter cubed. And so now, how do we find our percent error? Well, we just simply plug these values into the above formula. So let us take the measured value of 2.65. Actually, let's do it like this. Let's say our percent error is going to be our measured 2.65 minus our actual 2.70. And remember, you see, this value would actually yield a negative number. So you have to always remember to keep your absolute value. So we take the absolute value of this divided by our actual again, which is 2.70. And this whole thing is going to be multiplied by 100. This gives us an answer, or further simplifying, is 0.05 divided by 2.7 times 100, which gives us an answer of approximately 1.85%. And this here is going to be our percent error in this case. So your percent error is 1.85. And, it's a small difference, but then again, this is how you show that level of, precision. All right, let's look at another example. Okay, let's say that we have a chemical reaction, right? So in a chemical reaction, a student is going to produce 1.92 grams of copper. And we know that the theoretical yield for this reaction is 2.2 grams. So what is the percent error? So really the only difference here is just the wording, right? You need to be able to, if you're given a word problem like this, if you're in a lab and you're really trying to find the percent error for your own data, you're going to know what your data is, since you'll know what the measured value versus the actual is. But if it is a word problem in this way, you have to be able to identify from the wording what is the measured and what is the actual. So based on the wording that I just mentioned, the student produces 1.92 grams of copper, which means that 1.92 is going to be our measured. So our measured in this case is 1.92 grams of copper, and our actual was given that in that theoretical yield. The theoretical yield is 2.2 grams, and so that theoretical value is going to be the actual, right? Like what we should have gotten. So what is the percent error? Basically, we're seeing by what percent is our measured value deviating from what we expected to get, or our theoretical value, right? Well, just like before, our percent error is going to be the absolute value of 1.92 minus 2.20 divided by 2.20, all multiplied by 100, giving us 0.28 divided by 2.20 times 100, which is approximately 12.75%. That is our percent error. All right. Now let's just look at one more example. So let's say that a student determines the molar mass of an unknown gas by using the ideal gas law, right? So they calculate that value to be 65.4, right? 65.4 grams per mole. And the true molar mass is 58.44 grams per mole. And so we have to find what the percent error is. So now, if this is the value that they calculated, and this is the true molar mass, can you take a minute to figure out what the measured and what the actual is going to be in this problem? Well, I'll assume you took a minute. The measured is going to be 65.4, and your actual is going to be 58.44. So hopefully you got that correct. So now just plugging this into the percent error formula, we will be getting the absolute value of 65.4 minus 58.44 over 58.44, all multiplied by 100, giving us an approximate answer of 11.91%. So this here would be our percent error for this problem. So now before we just end the video, let me just quickly go over some common errors that students tend to make with percent error. Alright, so number one is using the measured value in the denominator, right? Mixing up the formula is obviously the number one way you can make a mistake. If you use the wrong formula, you'll get the wrong answer. So remember that at the end, you're dividing by the actual. It's the absolute value of measured minus actual divided by actual. Next is forgetting that absolute value. Again, always keep in mind that your percent error is going to be positive. It has to always be positive. So if you see yourself getting a negative value, you likely forgot to do the absolute value of the numerator here. And so those, I guess, are the the main things that you can mess up on. So once you know what to look for, percent error becomes pretty much a free point on every exam and every lab report. So hopefully you got some value out of this video. I hope everything made sense. Please show your support by liking, subscribing, and leave in the comments what you guys would like to see next. I'll see you in the next one.